Video lesson 13.6. This is the exterior angle video. So first off, let's again define what an exterior angle is with respect to the circle. And in this case, that's when you have the vertex of the angle is located outside of the circle. So again, you're going to have line segments that are coming together outside. Now, the difference here is that we haven't talked too much about those types of lines and what they're called. So we've got three scenarios that can create these exterior angles. That first one is that we have here is two secant lines. And a secant line is just simply a line segment that intersects the circle twice and extends outside of the circle. So just think of it as a chord, right, that extends out of the circle, right? So it can add that part. So I got two secant lines in any format. When they come together outside of a circle, we've got this exterior angle here, which in this example would be out here. The second one is we could have a exterior angle formed with one secant line, and as we've already discussed, a tangent line, which is a line that just intersects the circle at one and only one point. So no matter how long you draw that line, it will only intersect the circle at one spot. The best way of thinking of that is a line that just touches the edge of the curve there. And last but not least, we could have one that is created by two tangent lines, like so. So that's the way we're going to get these exterior angles. So again, here, either version, this is the angle that we're talking about. And so now that we know how they are created, let's get the rule. And that is that half the difference of the two intercepted arcs formed by either the secant or the tangent line, or a combination of both, will be equal to that exterior angle. So again, I like to create a little formula for it. I think it just helps in this example for your memorization. In this case, it's very similar to the interior angles that we did in the last video, but there is a major difference, and instead of the sum of the arcs, this is the difference of the arcs. So in this particular example, right, we've got the big arc, which in this example is AB, right here. So that's this portion. And we've got the smaller arc, which in this example is CD, which is here. So all we're doing here is subtracting them and dividing by 2, and that will create the value of that exterior angle. In this example is P. All right, so let's go and do some practice problems with these to see how that can be done. And again, the good thing is it doesn't really matter as long as you can identify that you have secants and or tangents and that exterior angle exists, then this rule can be applied. It doesn't really matter which type of segments you have, as long as you have those segments, the secant and the tangent lines. So in this particular example, though, for example number 1, we do see that we have two secant lines. Again, as it doesn't matter, but it's good to be able to identify what they are, forming it. So here's my exterior angle. So like I said before, we're going to use our formula. So we're going to say the angle, or the exterior angle, I'll abbreviate that, exterior angle equals big arc minus little arc, all divided by 2. So in this case, we don't know the angle. That's my x. I look here, I see big arc. In this example is the arc that's further away from the angle that we're looking at, and that is going to be 70. We're going to subtract the smaller arc, which in this case is the arc closer to the exterior angle, so that's 30, all divided by 2. So we can now solve. 70 minus 30 is 40, divided by 2, so we get 20 degrees for that exterior angle, which in this case is equal to angle X, or angle CPD, or even BPA. Again, any variation of that is fine. All right, so let's take a look at example number 2. In this one here, notice we've got one secant line and one tangent line. And that's how we create this exterior angle. So here's my secant line is in blue. My tangent line is in red. And that creates two arcs. Now, when you have a tangent line, because it only intersects once, right? So we've got here, this point right here. So notice we're going to have an arc that goes from the secant line to the tangent line here. So B to E. And then the other one is going to be from E to D, like so. So they come together, but they are broken up at that point. So if we're looking for the X value, notice the X is one of the arcs. So again, angle equals, or I should say exterior angle equals big arc minus little arc, all divided by 2. So in this case, we do have that exterior angle. It's 45. Big arc is, again, the arc further away from the exterior angle. That's 90. We're going to subtract the closer arc, which is the small one, which is X. And again, all of that divided by 2. So again, solving for X here, I'm going to take this and I'm going to multiply the entire right side by 2. And whatever I do to one side, I have to do it to the other. That will eliminate the denominator of 2, or aka dividing by 2, by doing its opposite. So now I have here 90 on the left side, and I'm left with 190 minus X on the right side. And now all I got to do is solve for X. And again, whichever variation you want to do here is fine with me. If you want to subtract each side by 190 degrees, isolate the X. So I'm going to have negative 100 is equal to negative X. If you do it this way, just be extra careful. You don't lose that negative sign, right? I'm sorry, the subtraction sign, which makes it a negative. And then you also have one extra step by just simply dividing each side by negative 1, again, or just thinking of it as the opposite. Whichever version you want to do, that's fine. If you prefer, or in the way I kind of think about it in my mind, or you can write it out if you want to too, instead of having to do that, I can just simply rethink this thought. So if I'm just going to rewrite this here for 1 minute, right, I could just simply say, well, if I minus the 90 over and then add the X to the other side, I get rid of that whole negative issue, and I'll have X is equal to 100 all in one step. So again, whichever variation you like to do is perfectly fine. Does not matter. It's completely up to you, just as long as you be careful with the math. All right, example number 3. Another one here where we're looking for the arc, and this one is formed by 2 tangent lines here. I'm sorry, 2 secant lines. My apologies. So once again, angle equals big arc minus little arc, all divided by 2. We have our exterior angle, which is 30. Our big arc, which is the further away one, 120. We're subtracting the smaller arc, closer one, and we're going to divide that whole right side by 2. So once again, multiply both sides by 2. That's going to get me here as 60 is equal to 120 minus X. Like I said, I prefer to do the whole minus 60 add X thought process. So I get X is equal to, in this case, 120 minus 60 is 60. So my X is 60, or again, if they specifically ask in the question, what is arc CD, right? We could then say that arc CD is 60 degrees. Again, formally, whichever way they ask you is how you should place your answer. So again, not a big deal. It's just a matter of being careful with the algebra, really, specifically that subtraction portion and dealing with the negative. All right, last example. This is not too bad of a video here. So let's identify here that I have 2 tangent lines. Again, even though they don't extend past, you could, right, extend this line segment if you wanted to. Right, just think of it as it's continuing on this way or continuing on that way. Right, and it would not intersect the circle any other spot, so therefore you know that these are tangent lines. All right, when doing these. So again, doesn't change the process. once I identify this, that I have that exterior angle, right? We're going to have the exterior angle is equal to the big arc minus the little arc divided by 2. So I've got 70 is equal to, again, big arc in this particular case is the, again, further one away from the angle. So that's the x. The closer one is the interior one, which is 110. And if I go to solve this, I can, oh, sorry, I'll divide by 2, right? And then if I go to solve this, we multiply both sides by 2. I've got 140 is equal to x minus 110. And now I can simply add the 110 over, because x will then be alone if I did that. So x is equal to 250 degrees. Therefore, arc, in this case, it would be FCE equals 250 degrees. So not a bad one at all when doing this, right? Now, in this particular case, I'm sure some of you are probably sitting there saying, well, Mr. M, I didn't have to do all of that. And you're right? Because of the context of this question and what the information is given to you, and the way that you're dealing with these two tangent lines, you could have just simply said, well, they intersect here and they intersect here. So, you know, I know if this blue portion is 110, the other portion has to make 110 plus something has to be 360 degrees, because that would make a whole circle. And you're right, 100%. Obviously, if you don't have the angle and you're looking for the angle portion, you're going to have to use the formula for those. The other thing is these questions could be algebraic, right? You could have an algebraic expression for this. So you still need to pay attention to that process. The algebraic expression ones, obviously, they just require a little bit more math in terms of the algebra. But in terms of the geometric setup, it would be exactly the same. All right. So again, feel free to go back over any parts of the video that you might need a little bit more clarification on, or to take more notes on. And don't forget to utilize the practice problems for better understanding.